All right. So we've got one more section in chapter 6. Doing a little bit of three-dimensional material. Okay. We won't be here too terribly long today. This is a pretty short section. Okay. So some of the formulas get really messy if you get too deep into doing all this. So we'll do the not so bad parts. Okay. All right. Anybody have any just general type of questions or Hawks questions or anything?
What is the Hawks thing? I cannot get it.
Which let's see. Oh, okay. Yeah, we'll look at it before we go.
Like I keep trying, and I was like, till 2 a.m. And now it's like already like 3 days late.
Oh, that's okay. If it's less than 7, it's still 90%. So yeah, we'll look at it before. If it's less than 7 days late, it's still 90%. So yeah.
I'm like one either I have it flipped around, or I'm like one number off.
Okay, yeah, that's all right. We'll look at it and we'll get it before we head down. Okay. All right. You might think anything else? Anything else going on? Okay. All right. So last time we did two-dimensional stuff. We did perimeter, right, where we're kind of figuring out how far, if we were walking around a flat shape, okay, how far would we have to go? And then we did some area, and so like we're painting a flat shape or covering it up somehow, or you can just think about the space inside the flat shape, then that was our area. Okay. So we're moving into 3 dimensions today. Okay. So our first thing we're going to look at the volume. Okay. And you probably already know this, but when we're talking about volume, okay, we are in 3 dimensions, so that's our world we're used to being in. Okay. So for volume, we're thinking about, you can think about like a box, kind of like an empty box, and volume is how much stuff we could put in our box. Okay. Or you could think about if we have some kind of 3-dimensional shape, how much space does it take up? Okay. Bless you. Be our volume. Okay. And since we're in 3 dimensions and doing a 3-dimensional measurement, we get cubic units, or units to the 3rd power. So we have like cubic feet or cubic centimeters. With area, we had square units. It was 2-dimensional. That's where we're headed. So we're just going to start off looking at some of the formulas. Again, you don't have to memorize any of these. They'll be on formula sheet on test day, but you might want to get them down so you'll have your list ready for doing the assignment. Okay, they're not too bad. So let's see. Our first shape, we'll start off with the rectangular version of a 3-dimensional shape. So we have a rectangular solid, or you might see it called a rectangular prism. You can just say a box. We've got a box. So here all we're doing, if we had a rectangle, so flat 2-dimensional rectangle is length times width. Lets you. So now we're adding 1 dimension. We just multiply by our height or our depth, if you want to think about it that way. And again, it doesn't matter which one of these you call L, which one you call W, which one you call H. Not in math class anyway. Okay. One little pet peeve here when we're talking about the dimensions. Okay. So we have length, we have width, and then the last one, a lot of times in the South, we say it wrong. Not just in the South, but especially in the South. Okay. And the last one is height. A lot of people, especially in the South, when they say say height, put like a TH on the end of it, because the other two have a TH. It's not, it's just a T. Okay. Length, width, and height. Okay. I'm not gonna give you a hard time if you say height. with the TH, but just know it doesn't have the extra H. All right, so there's our volume formula for a box or rectangular, solid, whatever you want to call that. Again, we could have a special case where all of our sides are the same length. So in 2 dimensions, we call that a square. What do we call it in 3 dimensions? If we've got a box where all the sides are the same length. What's that? Anybody got it? A cube, yeah, it's a cube. So if we have a cube, just like when we went from a rectangle to a square, you can still do length times width times height. But it just turns out that since they're all the same, we just end up with the same number cubed, so we can just say side cubed. That's okay. That's your cube. So a little math trivia, this one's harder to think about, but you can go to more dimensions with mathematical objects than 3 dimensions. It's weird because we live in a 3-dimensional world for the most part. But if we could go to 4 dimensions. Anybody know the name of a 4-dimensional box that all the sides are the same length? So it's not a cube. There's a 4-dimensional version that has a name, you know? There's a movie that's named this. It's an old movie though. Nobody got it? So if you're on Jeopardy, you're striking out, huh? It's a hypercube. We call it a hypercube. So, old movie, it's kind of good if you want to watch. So we're not gonna have to worry about that, okay, for sure. But, all right, so there's our cube. The next one I've got on here is a sphere. Okay. But actually, we don't. When I double checked, I didn't give you any of these problems in the assignment, so you don't even have to have that one. Okay. But just if you wanted to see the formula volume of a sphere, okay, you figure out the radius. It's 4/3 pi r cubed. You don't have to have that one on your list for the assignment, okay? And I won't put that one on the test because it's not in the assignment. I just didn't realize that I didn't give you one of those. And one more we do need. And our text gets wordy with naming this shape. Okay, it calls it a right circular cylinder. But as far as I know, if you say cylinder, that's what you mean. You mean a right circular cylinder, okay, unless you're specifying something else. So you can just say cylinder. That's okay. So the idea here, we've got a circle on top and bottom. Right. And we're just kind of taking a circle and like stretching it out into 3 dimensions. Just like a soup can or paper towel roll or something like that. It's our cylinder. So our formula, again, you can, if you think back to 2 dimensions with area, you can kind of see where we get our volume formula from, because if we just do pi r squared, that's the area of the circle on the end. Pi r squared is the area of the circle. And then we're just multiplying it by how tall it is. Okay. Pi r squared h. Okay. All right. Our problems are a little more interesting in this section. Most of them are not just straight up using the formula. We had to think a little bit. In the assignment, most of them are just plugging into the formula. It gives us something a little more interesting to talk about in class. So let's look at one here. Okay. It says, assume you want to build a concrete patio in the back of your house, and we're assuming here it's rectangular. It doesn't spell that out for us, but okay. I guess because it gives us length, width, and depth, we're supposed to know it's rectangular. Okay, it says the patio is going to be 18 feet long, 12 feet wide, and 6 inches deep. Part A, we want to know how many cubic yards of concrete we need to build the patio. Okay. So volume of a rectangular prism, rectangular solid, length times width times height, or here, well, it's calling it depth because it's going down. But we have a little bit of a curve thrown to us. Anybody see what the issue is? Well, we've got a couple of things actually. Yeah, so here we've got feet, inches. And then the question it asks us is cubic yards. Okay. So we've got some unit conversions we need to do here. Okay. So two good ways you could do that. You could maybe change everything, change our 3 dimensions all to the same unit. So maybe you could change them all to feet. And then at the end, when we get our volume, we could convert that to cubic yards. That can be a little bit confusing, and I'll show you why when we get there. But I think this one's a little bit easier if we convert our units first to match our answer. So here, what I'm going to suggest is that we take our length, width, and depth and change it to yards before we find the volume. Okay. So I'm going to copy our measurements down here. We've got 18 feet, 12 feet, and 6 inches. And let's change all 3 of these to yards first. So might have to refresh your memory a little bit. So the first 2, we're going from feet to yards. So how many feet are in a yard? You remember? 3. We've got 3 feet in 1 yard. So here we can divide our first 2 by 3. That'll get us to yards. So 18 feet, that's 6 yards. 12 feet, that's 4 yards. The last one's a little bit trickier because we're starting off in inches. So it's going to be, you could change it to feet first and then change it to yards, or we can just figure out our conversion factor for inches and yards. So if we have 3 feet in a yard, how many inches are we going to have in a yard? 36, yeah, there's 12 inches in each foot. We have 3 of those, we get 36 inches. So we can divide by 36 here. And we're going to get a decimal. That's okay. I'm going to round a little bit. It's 0.166666666, so I'm going to round to 0.167. Okay. So then for our volume, we just multiply them all together. 6 times 4 times 0.167. See what we get here. So this one, I get 4.008 because we rounded a little bit, so I'm just going to call it about 4. And then now we're in yards. And since it's volume, we have cubic units, so cubic yards. That's how much concrete we would need for our patio. Okay. I said that you could convert the units at the end into yards. Let me show you one that can be a little bit tricky. So we said we have 3 feet in 1 yard. But if we're trying to convert that to cubic units, we've got to cube both sides. So then on the left side, we have to do 3 times 3 times 3, 3 cubed. So that would be 27 cubic feet. Is 1 times 1 times 1 cubic yard. That's a little tricky to kind of think your way through if you're not expecting it. So it might be easier to convert the units first. So anyway, we got 4 cubic yards. Okay. Yes, I'm sorry. 3 feet in the yard. Yeah. And then 36 inches in the yard. Yep. Any other questions? All right, so now we got a part B. That's part A. Part B says if a concrete mixer truck holds 5 cubic yards of concrete, how many truckloads do we need? This one's easy. The truck holds 5 cubic yards. We need 4 cubic yards. How many truckloads do we need? Just one on this one actually, right? Because the truck holds 5. We only need 4. So part B, we only need 1 truck. So yeah, if you were thinking like if we needed 5 and it held 4, then it would be 2. Yeah. That one's so easy it almost makes you overthink it. Questions on the formula part? Good. All right. Let's find the volume of a weird shape. Okay, we've got our formulas we can use for the nice shapes, like cylinders and cubes and things like that. But, what do we do if we have something weird shaped? Let's look at this swimming pool here. Okay. It says we want to build a swimming pool in our backyard, but the city where we live has a restriction on the volume of water the pool can hold. Yeah, weird regulations like that some places. It says the restriction is that pools may contain at most 4,800 cubic feet of water. Our plans are to build a pool that's 16 feet wide by 24 feet long, and then the depth makes it a little complicated. And it says it starts at 2 feet deep and then slopes down to a depth of 12 feet. We want to know if our pool's legal. So this one, it's helpful to make a sketch, and since it's 3D, we can kind of think about it from side view and then from top down. It helps to have multiple views of what's going on here. So here's our pool. There's a side view. It's 24 feet long, so we've got that part. And then it starts off 2 feet deep and then ends up 12 feet deep. Okay. And then we don't need it just yet, but here's our top-down view. Right, it's 24 feet long and then 16 feet wide. So if we have some kind of irregular shape, instead of just having like 50 different formulas, we can kind of just think about it a piece at a time. So I think this one's easier to start with the weirder shape first, right? We can start with the side view first, sorry. Let's start just focusing on the side view. So what we can do is if we can figure out the area of the side, then we can just multiply by how wide the pool is, and we'll get our volume. So if we're looking at that side view, what shape would we call that? I think I heard it real quiet somewhere. We got 2 sides that are parallel, 2 sides that are not parallel. It is quadrilateral, it's a special kind. I think I heard it. It's a trapezoid. Trapezoid. Yes, trapezoid. So we can break out our area of a trapezoid formula from the last section. Okay, so that says the area of a trapezoid is 1/2 base 1 plus base 2 times h, times height. Okay. So the bases, B1 and B2, are always the sides that are parallel to each other. It doesn't matter which one you call 1, which one you call 2. So here, like this could be B1, this could be B2. And if we're doing that, if we're calling those the bases, then we can think about rotating this thing. So like this is going to be the bottom. So then that would make 24 be the height. Here h will be 24. So then we can plug into our formula. So 1/2 of 2 plus 12 times 24. So there we'll get an area 168 feet, and since that's area, that's feet squared. Okay. How to make it three-dimensional and get our volume, we're only missing one dimension. Okay, we're missing the width of the pool, how wide the pool is. So we can take our 168 square feet, multiply that by how wide the pool is, 16 feet. We get our volume, 2,688. It's feet, and it's volume, so it's cubed. And you can even check to make sure the units make sense. Here we've got feet squared times feet, so we'll get feet cubed. It's like x squared times x is x to the third. There's our volume. And so if you have a weird shape, that's a good technique. Figure out the area of one side and then multiply through by the other dimension. Answer our question, is our pool legal? Our volume is 2,688 cubic feet. It said the maximum we could have is 4,800 cubic feet. So yeah, our pool's legal. We could make it bigger if we wanted to. Okay. So we're within the law on that, okay? Questions on that one? The squared, okay, so we started off by finding like the area of the side view. So the square units come in from finding that area. And then we're multiplying through by the width. That's just one dimensional, so that's just regular feet. But when we multiply them together, we get the cubic units. Third power there. Most of the ones we've worked, we haven't like done it separately. We've just done it all at one time, so you just end up with the end units. Okay. Other questions on that one? Okay. All right, let's look at one that's a little controversial if you're a drummer. It says the sound a drum makes varies according to the diameter and depth of the drum. Okay, sort of. Assuming that the materials for the make of the drum remain the same. So what we're going to do on these two, we're going to find the volume of air in two different drums. Okay. Part A, got a drum that has a diameter of 14 inches and a depth of 5 inches. Okay, so here's our diagram. Okay, so we're dealing with a cylinder. Okay, so if we want the volume of a cylinder, it's pi r squared h. The thing we have to look out for is this one does not give us r, it doesn't give us the radius. It gives us the diameter all the way across. So we've got to divide that by 2 to get a radius of 7. And then we can plug in. So remember, for pi, we're using our estimate of 3.14. If you use the pi button, your answer will be a little bit different than what we get here. Okay, so R7, so 7 squared, and then times 5. Okay, so on this one, I get 769.3 inches in its volume, so we have cubic inches. Okay. So really the only two common mistakes I see very often on these is you forget to get the radius and you put 14 in instead of 7. Or occasionally I have people get in a hurry and they'll square the 5 instead of the 7. I want to square the radius, not the height. Not too bad. Be aware of those couple things. And then part B, same idea. We're still going to have a cylinder, right? Because we've got the same basic shape. Their dimensions are just a little different. On this one, it does give us R. Okay, so the radius on this drum is 5. So we'll have 3.14 times 5 squared times our height is 8 inches this time. Here we get 628 inches, and then its volume, so cubic inches. So this is not a physics class, but the idea here is supposed to be that the one that has more air in it, you would expect to have a lower tone. Okay, that varies. And there's other factors that go into it. Okay. Until our textbook author was not a drummer. Anybody play drums in here? I know I've got a few drummers in another class. So. Okay. I was a band nerd and a drummer. So. Okay. So that's volume. Okay. If you're good at plugging numbers into formulas, then you've got it. Okay. Most people don't have too much trouble with volume and area. Okay. This last calculation, last measurement we want to talk about, okay, is a little bit weirder. Okay, it's surface area. Let me get to it here. So surface area is a little bit weird because we normally only talk about surface area when we have three-dimensional objects, but surface area is a two-dimensional measurement. It is area. Okay, but what's going on here if we think about our three-dimensional box? Okay, we're thinking about how much stuff would it take us to like cover up all the sides of our box. So you can think about like how much wrapping paper would it take to cover a box. Okay, that's surface area. Okay. So we're not thinking about how much it holds, we're just thinking about like if we want to cover it up. Okay. What will we get? So again, this is area. Even though we're dealing with three-dimensional objects, this is area, so we still have square units, even though we're dealing with a three-dimensional object. So have kind of a weird mix of 2D and 3D with surface area. Okay. So let's look at our first surface area here. And so the first one is a rectangular box, okay, a rectangular solid. And for these, our textbook gives us a formula. And you can use it if you want to. But to me, this formula you can get confused trying to use the formula sometimes. So it's better if you can get an understanding of what we're actually finding. Okay, so if we have a box, and I don't have a box with me, we'll use our sponge here, okay? Because it is rectangular. It's a rectangular solid, right? If you don't count the corners being rounded off. Okay? So we have a rectangular solid. All we're doing here is we're finding the area of each one of the faces, what we call them. Okay? And then we're adding all those areas together. That's surface area. Okay? So like this first part says 2 times the length times the width. Okay? All that's saying is we've got a front in the back that are the same dimensions. So figure out the area of one of those, and since we've got two that are the same, multiply by 2. Okay, so it's like that first part's just saying find the area of the front and back. Okay. The second part, 2 times length times the height. So all that's saying then is the left side and the right side are going to be the same dimensions. So figure out the area of one of those and multiply by 2. So that's all we're doing is we're finding the area of the left and the right. And then the last one is saying the top and the bottom are going to be the same dimensions. Okay. So find the area of one of those and multiply by 2. So we just really have 6 faces we're finding the area of. We got front, bottom. It's just, we're finding the front, back, left, right, top, bottom, adding all those together. That's surface area. Okay. If you want to use the formula, you can. If you get the idea, you don't have to use the formula. Okay. Okay, let's look at one. And right away, we get a little bit of a curve. Okay. This one says, Amy's icing a cake for her sister's birthday. It's a half sheet cake, measures 12 inches by 18 inches by 2 inches. We want to find the surface area of the cake that needs icing. So the little bit of a curve we have on this problem is we're not just finding the straight up surface area of a rectangular box. What we're doing, we're thinking about what parts need icing. So normally on a cake, what parts do we ice? We ice the front, the back, the left, the right, and the top, but usually not the bottom. We normally don't, you could, okay, but normally we don't put icing on the bottom of the cake. Okay? Makes it slide around. Okay? On the sheet. So we just need to remember we're going to leave the icing off the bottom. Okay? So here's a little sketch. Okay? There's our cake with the dimensions on there. So to me, it's easier just to think about the pairs of matching sides. Okay? So if I want the surface area, I'm going to do the front and the back first. Okay? So the front would be 18 inches by 2 inches tall. So 18 times 2. That would be 36 square inches. That's the front and back. Okay. Then we can do the left and the right. So the right side's easier to see on the picture the way it's drawn. So the right side would be 12 inches by 2 inches. So 12 by 2. That's 24 square inches. Okay. And then each, right? We got 2 each of those. Okay. Let me fix that before we forget. Okay. Okay, so times 2 on this one for left and right. And then for the top, we won't multiply by 2, right? Because we don't want to do the top and bottom. We just want to do the top. So the top would be 18 by 12. Okay, so what is that? 216. Okay. Then we just add all those up. We get our total surface area. 72 plus 48 is 216. So that's adding the front, back, left, right, and top all together. Our total surface area we need to ice, we've got 336 square inches, not cubic, square inches. Did I lose you anywhere there? Especially since I had to back up because I forgot to multiply by 2. You okay? Good with it? Okay. If it was just asking for the straight up surface area, this one we would multiply by 2 also and add them all together. But we're leaving the bottom out because we're not going to ice the bottom. And part B has nothing to do with surface area. It says if the cake is cut into pieces that are 2-inch squares, how many pieces of cake can be served? So here we can just think about the top-down view of the cake. So it's 18 by 12, so we just have a rectangle. And it's saying we're going to cut it into 2-inch squares. So the area, okay, the whole thing is 18 by 12. And we can figure out the area of each slice. And so they're 2 by 2, so the area of each slice would be 4 square inches. And then we can just divide. We'll get 54 slices of cake. Those are little bitty pieces though. You'll get 54 slices out of that. And you could, okay, if you really wanted to, you could count also, right? So you could say, this is 2 inches, so it would be 9 slices across, right? So 18, right? And then 2 inches would be 6 slices up, right? 9 times 6 is 54. So you could do it that way too. Okay. Questions on any of that one? Hanging in there best you can. Okay. It's like our Friday in here, so that's exciting. Okay. We're winding down. Okay. So that was the surface area of a rectangular solid or a box. Okay. Again, if you're dealing with a cube, and all the faces would be the same, so you could figure out 1 multiplied by 6. Okay. Nothing really revolutionary about that. We will do one sphere here. Okay. We'll do surface area here. Okay. The surface area of a sphere is 4 times pi times r squared. Let's look at one of those. Okay. So I'll write down the formula again if you need it. All right, so we've got a manufacturer of baseballs. It says if a baseball has a diameter of 3 inches, what's the surface area of the baseball? Okay, so here, if we're thinking about a flat shape, it's saying the diameter is 3 inches. If we're trying to figure out the surface area, we don't need the diameter. And we need the radius. Okay, so a radius here, we would divide by 2 and get 1.5 inches for our radius. Sorry. That's R. That's really the only tricky part of that one. So here we got 4 times 3.14 times 1.5 squared. Okay. So we get 28.26 roughly square inches. Not bad, just plugging in the formula. That one, if you're a baseball person, that one's a little bit interesting. So if you think about a baseball, I wouldn't think, just thinking about it, that it would take almost 30 square inches of leather to cover a baseball. It does. Okay. One more surface area formula. Okay. We're winding now. Okay. And one more surface area formula, and that's if we have a cylinder. Okay. So on this one, the formula is helpful. Okay. And so we've got 2 terms in our formula for surface area of a cylinder, and it can be helpful if you know which piece belongs to what part of the cylinder. Okay, so this 2 pi r squared is the area of a circle. We've got a circle on the top and bottom of our cylinder. So that part is found in the area of the top and the bottom. And then this part, we're found in the area of the side of the cylinder, like around the can, like the area our label would go on if we had a soup can. Okay. And that part is like, if we unroll it, it's like a rectangle. So if we have a cylinder and here's our cylinder. If we cut it down the side and unroll it, we get a rectangle. So that's all this is. This is the radius. Okay, tells us about one of the dimensions, and then this dimension, and then the height tells us about that. So 2 pi r is circumference times the height is all it is. You don't have to get that detailed with it. Okay. So one more problem. Short section. At our last problem here. It says find the surface area of a cylinder with a radius of 4 centimeters and a height of 10 centimeters. Okay, so this one does give us the radius. So if this is our top, we're saying our radius is 4 centimeters. And then we've got this thing going on. Said we're 10 centimeters tall. Sketch can help. You obviously don't have to be able to draw well, because I can't. And so here's our formula again, surface area of a cylinder. Make sure I don't mess it up. 2 pi r squared. That's the area of the top and bottom, plus 2 pi r h, the area of the side. Okay. So we've got 2 times 3.14 times 4 squared plus 2 times 3.14 times 4 times 10. And so we got quite a bit to type in the calculator, but we'll let the calculator do the work. And so here I get 351.68. We're in centimeters. We're doing surface area, so square centimeter. Let me double check that, make sure that's right. was good. Question on that one, formula is a little messier, but it's the same types of numbers we've been dealing with. We still got radius and height. Okay, so not really dealing with anything unusual there if you have the formula. Nothing there? All right, that's all for chapter 6. Okay, so enjoyed the short day. Try to get out of here before it starts pouring down rain. If you didn't get on the sign-in sheet, make sure you get on there before you leave, and I'll see you next week. We got 2 sections out of chapter 7 to do next week.